Hey, did you guys have fun at the soda can baseball? Soda pop baseball? Good. That was mayhem, is what that was. I'm glad though. It's good to see you guys having fun.
Mayhem was great. We've been every day since getting the
Right.
playing with it.
I'm gonna pause this real quick. So today is 9:25. Wow. And we are going to, I think I'll just head this lesson because really it's the bulk of what we're doing today. We're going to learn something today called synthetic division. It's a very simple skill. Once we get right into the lesson today and we actually learn the mechanics of this is how you do this, not only will you get it, but you might actually enjoy the process. I was talking to my wife about this last night at when I visited with her when I got home, and she's like, I remember synthetic division. She goes, I like that. My wife's kind of a nerd, but I think a lot of people share the sentiment that there's something cathartic about the process of doing synthetic division. So math person or not, it's a bit enjoyable. There's a little bit of background to it, so I just kind of have to give you the setup, and then once we get into the mechanics, we'll probably fly through the vast majority of this. So the setup for today's lesson is we really need to study, or maybe not study, but talk about the meaning of the word factor. And when I say the word factor, I want to make sure you understand that I'm talking about the word factor as a noun, not a verb. We all know the verb to factor, what it means. It means to take something and break it down into pieces that multiply to make it, right? You've been factoring since probably the fourth grade, just not with X's. Like your teacher taught you how to factor the number 12, for example, down into 2 times 6, right? That's called factoring. So when we talk about the word factor as a noun, a factor of something is something that divides evenly into something larger, correct? So like we would say that 2 is a factor of 12 because if you divide 12 by 2, what don't you get? You don't get the R word, a remainder, right? Like what happens if I try to divide 5 by 3? I can't, right? I mean, I can, but if I took 5 divided by 3, then I don't get a whole number. I get if someone really taught you how to do division like super old school correctly, 5 divided by 3 is 1, but 1 times 3 is 3, and 5 minus 3 is 2. So we would express this in very proper terms as 1 with 2/3 left over. Correct? So when a remainder is required, then we say that this number is not a factor of the dividend, correct? Mm-hmm. So if we apply that to algebraic thinking, the question becomes something like this. Is x minus 6 a factor of x squared minus 4x minus 12? So we jumped up quite a bit there, right? From talking about fourth grade division up into 11th grade math, right? So if I asked you, is 4 a factor of 20? You'd be like, well, yeah, of course it is, right? And we can prove that because we can show someone that 4 wholes times 5 wholes makes 20, correct? No decimals or remainders required. So the question here is, can I prove to someone or disprove, does x minus 6 go into x squared minus 4x minus 12? Can anyone think of a way to answer that question? If little Johnny was sitting in class and Mrs. Schlockendeimer said, hey, little Johnny, is 4 a factor of 32? And Johnny goes, yeah. And Mrs. Schlockendeimer says, well, prove it to me. Then he could say, okay, well, I'll prove it to you by showing you that 4, if I multiply it by 8, equals what you said. And she'd go, very good, little Johnny. You just proved that 4 is a factor of 32, correct? So can I prove that x minus 6 is a factor of x squared minus 4x minus 12? How?
X is 4.
Careful, you're on the right track. But the question at this point is, can I take x minus 6 and multiply it by something and have the answer be x squared minus 4x minus 12? Yes, I can. I can prove, and if I'm good at factoring, which really by the end of September you should be, I can prove to someone that if I multiply x minus 6 by x plus 2,
Yeah.
it does work, doesn't it? That equals x squared minus 4x minus 12. So we just proved that x minus 6 is a factor of x squared minus 4x minus 12. When this becomes more difficult and where today's lesson becomes essential or like massively necessary is when someone asks a bigger question, like, is x plus 3 a factor of 4x to the fourth minus 5x to the third plus 6x squared minus 9? You're like, the heck am I supposed to know that? And that's where today's skill called synthetic division comes into play. Synthetic division is a way for us to check to see if a polynomial is a factor of a larger polynomial. And now I'm going to show you how this works. And for the first go round, you're going to be a little bit confused, maybe even the second go round. And then you're going to go, okay, I'm feeling the flow. But there's a way in mathematics to not, like, this is clunky. This little process we went through over here is clunky and dirty and ugly and messy, right? I haven't got time to sit around and check stuff and get all creative and artsy with it. So this is how we would set up that question that I just asked you in a mathematical way. So synthetic division is a shortened version of what we call polynomial long division, which I've made the choice we're not going to do, at least not right now. Okay, that day might come. But here's the setup. Look at the numbers in front of the polynomial. By the way, this is called the dividend. I don't think you probably remember that from the old days, but the dividend is what you're dividing. You're starting to divide it by something. That's called the dividend. And then x minus 6 is called a divisor. You guys remember those words at all? Dividend, divisor. And then what we're trying to calculate here is what's called a quotient. So if little Johnny's sitting in class and he does 24 divided by 8, 24 is the dividend, 8 is the divisor, and 3 is the quotient, right? So when we set it up, we're going to pay close attention for our dividends to the numbers, and I'm going to switch colors here. So look for the purple. 1 is in front of x squared, -4 is in front of x, and -12 is right there. You see those 3 purple numbers? I'm going to transfer them over here, and you are also just like this. Now, what we're going to do is we're going to set up a long division sign, but it's actually going to go upside down. And before you write it down, pay attention. I want to tell you something. Note that I am leaving room underneath. Sorry about that little notch there. I'm leaving room underneath the purple numbers for reasons you'll soon see. So go ahead when you're ready, set up a long division upside down sign like that. Now, in order to perform synthetic division, what you have to do is use the number that would make the divisor equal 0. So incoming green, there's no green on the board, so I can use it now. You see this green thing? What number could I put in place of x to make the green thing equal 0? +6, so I'm going to put a 6 right here. And what we're about to do is answer the question of, is x minus 6 a factor of 1x squared minus 4x minus 12? So here comes an algorithm. And sometimes in math, there's a lot of steps. Like you got to do like a ton of things. This is a 2 or 3 step process that just cycles and repeats itself over and over again. So you want to get really, really super good at it. I got to pause this real quick. Here it comes. And I'm well within my rights to ask you to memorize like 2 steps. So this is where I say you need to memorize this process. Here it goes. Step 1. When you do synthetic division, you take the first number and you copy it down below the division sign like this. That will always be step 1. Here comes the repetitive algorithm. 2 steps over and over again. You're going to take your green number. You're going to multiply it by your red number. What is 6 times 1? You're going to write that answer right here. And now we're going to add down the second column. What is -4 plus 6? I'll point to it right there. 2, correct? Write that answer right down here. Now take your green number and multiply it down diagonally. That 6, the green number, just keeps multiplying by all the guys we stick down on the bottom, right? What's 6 times 2? That goes here. 6 times 2, 12. Add again, what's -12 plus 12? This last number you get, you should always put a box around it. Trust me on this. That is called the remainder. And we just proved that x minus 6 is a factor of 1x squared minus 4x minus 12. If the remainder comes out to be 0, as I expressed earlier, remainder of 0 by definition means that whatever we divided by is an even. It's a factor, right? So did I lose you? Let's practice this again. So the answer of the question is, yes, it's a factor. Let's go again. Let's answer the question of, is x plus 3 a factor of blah, 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 blah. I'm going to write it out for you as an actual division problem. So here's what it looks like. 4x squared plus 7x minus 15. We're going to divide that quadratic trinomial by x plus 3. And the question implied here is, gosh, is x plus 3 a factor of 4x squared plus 7x minus 15? Now, again, we could do this like, brute force like we did the first one and just sit here and try to piece it together. Wouldn't be all that hard, right? But here we go. We're going to take the 3 purple numbers, 4, +7, and -15, and we are going to transfer them into their own little spot right here. 4, 7, -15. What's the next thing we do? The upside down division sign, and now you understand why we leave room underneath the purple numbers, right? Because there's numbers that need room to go there. Now, what number am I going to put? Who's going to be my green guy? -3, right? Because that's what makes the divisor equal 0. So very quickly now we're about to answer the question of, is it a factor or is it not a factor? Let's find out. Say again. Yeah, and I like to draw an arrow. I do that just about every time just to remind you. Don't put any numbers in that space. Just remember to bring the 4 all the way down. Kapow. Now, green times red, what do you get? It's going to be this diagonal division every time. Get used to it. -12. And then we add the second column, and what do we get? As Kaysen says, perfect. And now we multiply green and red again, right? What do we get? 15, and then we add the third column, and what do we get? So we answer the question, is x plus 3 a factor of the dividend? It is, because we got a remainder of 0. What we're going to do now for the next, what's up? Yeah, step 1 is bring down the purple number. The 4, you see the arrow that I drew? Bring it down. Now, steps 2 and 3 are going to repeat themselves over and over again. Are you ready? Step 2, follow my yellow sign here. Multiply these 2 numbers together. It's always going to be the number on the outside times the new number on the bottom. What's -3 times 4? That's why that number went here. Then the next step, and this is technically the last step because it'll just repeat itself. Look at the white arrow up here. Just add those numbers together. What is 7 plus -12? And that's why that number now went down here where I'm moving my pen, you see? And then the cycle repeats. We start with green guy again, and now we multiply him by the new guy on the bottom. -3 times -5 is, and that's why that went there. You see how the cycle has just started over? I'll help you with that as we go, okay? So, next one. And by the way, the answer to the question of is it a factor will be yes for a little while longer, and then I'm going to switch it to no. So just kind of know ahead of time I'm trying to give you some here to warm us up where they come out nicely, and then I'm going to change that up on you. So we're dividing a cubic 4-termer by x minus 2. And this now is where it becomes not impossible, but extremely difficult if you don't know how to actually mathy divide. If I said to you, is x minus 2 a factor of the big guy? Yeah, good luck with that. Good luck. I don't even know if I could, I don't know that I could do it. Like I'd maybe if you gave me a few hours and you know, a cold glass of lemonade and some positive words, but we're going to do it the mathy way. So we're going to take the numbers that are at the leading part of the long, the dividend, and they are 4, negative 14, positive 17, negative 10. And then we're going to draw an upside down division sign, leaving space. And what number is going to go on the outside? Positive 2. And the cycle begins. Step 1,
Okay.
drop your 4. Whether you draw the arrow or not, remember to drop it all the way down below the synthetic division sign. Got it? 2 steps now that you have to memorize for me. Multiply, add, multiply, add, multiply, add. You go as long as you need to until you reach this sweet coveted spot right here. That's the end of the problem. So let's get to it. What's 2 times 4? What's negative 14 plus 8? Negative 6. What's 2 times negative 6? What's 17 plus negative 12? What's 2 times 5? 10. Add those numbers together. What do you get? So once again, we just discovered that x minus 2 is actually a component building factor of that big, nasty polynomial. One more. You see in the flow of it, it's a very simple process as long as you're willing to just, if you're willing to just commit those 2 steps to memory, multiply, add, multiply, add. Actually, I think I have a couple more of these for you. So let's do x to the 3rd plus 3x squared minus 6x plus 20 divided by x plus 5. May I scroll? What are my 4 numbers for my dividend? Nice job. Upside down division sign. And who's my green number? That's the spirit. That's the setup. And to kick off this process, and here we go. 2 steps over and over again. You can see this is going to be more frustrating for someone who makes little mistakes. And I've been preaching that to you since I've known you about how you cannot mess up basic math. You're past the point in your life where that's like, we shrug that off. We don't do it. Might we once a month make a small mistake on stupid math? Yep, we're allowed that. But if it's more frequently than that, then you're just going to be miserable. Here we go. Negative 5 times 1, negative 5. And I'm going to stop switching colors because I'm getting tired of it. What's 3 plus negative 5? Negative 5 times negative 2, 10. Negative 6 plus 10, 4. Negative 5 times 4, negative 20. Add them together, 0. What's that? Where? This? Got it? Do you understand this well enough that I can omit the last example, or would you like one more before we get to the second half? Just press on. It's drop it and then go times add, times add, times add, times add. Like just till the cows come home. You just keep going. Same 2 steps. Okay. Now, let's take a look at this one. I haven't asked the question in a while, so here it goes. The question implied is x minus 3 a building factor of 2x cubed minus 9x squared plus 6x plus 10? In other words, when I divide this, will it come out evenly? If it does, like we learned in 4th grade, that means it's a factor. If it doesn't, then we're going to need the R word, a remainder. And I'll show you how to do the remainder, because hint, hint, this one ain't going to work. Okay, so let's get to it. Let's do the setup. What are my purple numbers at the top going to be? Upside down division. Nice. Green number? No. Positive 3. Remember, you got to make the divisor equals 0. So do the opposite, essentially. And we're off. You ready? Not asking that much. Just memorize a couple steps. Drop the 2, and here we go. 3 times 2. -9 plus 6. 3 times -3. -9. 6 plus -9. -3. Green number times -3. Houston, we have a problem. So when we perform division problems like this, the answer is not, and I've skipped a massive part that I need to go back and fix. It must be the tiredness, but for now I'm going to salvage this. Here is how you write your answer for this problem. See this 2? He is 2x squared. Do you see this -3? He is minus 3x. And do you see this -3? He's -3. It was pretty criminally offensive or unprofessional of me to have skipped this. Do you remember at the beginning how we started with our dividend having x to the 3rd? When you smack a problem with one iteration of synthetic division, 1, you drop that power down by 1. So sorry to ask this question, but what's 1 below 3? Hence my decision to put 2. These 3 numbers where this yellow arrow is pointing are the numbers that build what we call the quotient. Okay. Now there's a remainder, huh? So what we do is we put plus, and then we make a fraction. And what is the remainder?
1/3.
1. And what is the divisor?
3.
Nope.
2.
Nope. I'll give you a hint.
5.
It's in the red oval.
3.
X minus 3. The format, and you should write this down, the format of your answers will always be, I'm almost out of colors. The format of your answers should be quotient plus remainder over divisor. Let's go back, since your teacher forgot to mention this like a big old slouch, and let's talk about the numbers in this green box. You remember this from about 3 minutes ago when we got a remainder of 0? What will those 3 numbers give us for a quotient? Where did, yeah, remember this problem started up at x to the 3rd, so it'll drop to 1x squared minus plus. Wonderful. Let's go up again and practice that. Go back to the problem up above, the numbers again in the green box. It's going to be 4x squared plus, just like that. And there's probably another one yet again above that. Look at there. So in this one in the green box, my numbers are 4 and 5. What will my quotient be this time? Just 4x. Very good. And up here, look for the yellow circle that I'm drawing right now. Do you see it? It used to be x to the power of 2. So my quotient is going to be x to the 1 less than that. So these numbers in this green box over here imply 4x to the 1 minus 5. So your quotient comes from those numbers that you get along the bottom row. And then the question is, do I have to write a remainder or not? And we didn't have to in the first 3 examples or 4 examples, whatever. But now we do. Let's go again. And right about the time you get this, I'm going to mess with you now. So before you just march into this happy little journey, you might want to take pause. You ready? I'm going to write the purple numbers my dang self this time. I'm not even going to ask for your input. Here it goes. The purple numbers are 1, 7, 0, -11, and 9. And you and I now get to have this little discussion about where in the ever loving world did that stupid 0 come from? Can anyone spot it? He's missing, isn't he? Pay close attention. Look at these exponents. I'm going to make them yellow. There's a 4. There's a 3. We're working our way down. And who's missing? Right there would be a plus 0x to the 2, hence that 0 right there. It's a missing term, right? All holes have to be filled with zeros when you set up synthetic division. And then, of course, we have our exponents now. 4, 3, 2, 1, 0. Perfect. What's the green number on the outside going to be? Let's do this. And I'm not going to go slow because now what we have to do is multiply and add. We got this. Ready? What's 1 times 1? 7 plus 1. 1 times 8. 0 plus 8. 1 times 8. -11 plus 8. -3. 1 times -3. Add 9 and -3. The remainder is 6. So again, look in the upper left corner of the TV at the yellow circled 4. That means that the original degree of the dividend was 4. What will the degree of my quotient be? Correct. 1 less than what it was before. You just smack it down a layer. And eventually we're going to start multi-stacking synthetic division where you smack it, knock it down, you smack it again and knock it down again, you smack it again. You can do this over and over again, and I won't show you that today, but it's coming. So in the meantime, it started with a degree of 4, which means that these numbers right here are going to be a polynomial with a degree of 3. So let's do it. What does the 1 mean? 1x to the 3rd. What does the 8 mean? 8x squared. What does the next 8 mean? Plus 8x. What does the -3 mean? Well, -3. And what is the remainder? So I put plus a fraction, and that is 6 over x minus 1. Nice job, guys. That is how you do synthetic division. Yes, sir.
I don't understand how it is 0.
Because there's a missing term. Would you like to practice the 0 one more time? Let's practice the 0 one more time. I'll just make one up. How's that sound? Is that okay with you? Let's do this. Let's do 3x to the 5th minus 2x to the 3rd plus 3x squared minus 4. And let's divide it by, how about x plus 2? The probability of this being a remainder of 0 is like 0.0001%, right? Just make it up on the fly. You should probably expect a remainder, just FYI. So to help you out with your question, here's what I need you to see. If I wrote this polynomial, pay close attention now. If I wrote this out properly, this would be 3x to the 5th plus 0x to the 4th minus 2 x to the third plus 3x squared plus 0x minus 4, color coded for your educational convenience. Do you see where the zeros come from?
Yeah.
They fill in the missing places where the exponents don't descend correctly. You need it to go down perfect. 5, 4, 3, 2, 1, 0, or 4, 3, 2, 1, 0. And anyone that's not present and accounted for gets a 0. So let's make our purple numbers now. Does that answer everyone's question of where the zeros come from? Wonderful. So here we go. Purple numbers. 3, 0, -2, 3, 0, -4. Upside down division sign. What's my green number? And we're off. And if this comes out to be a 0, I'm gonna go buy myself a lotto ticket today. Okay, so let's do this. Step 1. And we begin. 2 steps. That's what I'm asking you to memorize. What's -2 times 3? -6. What's 0 plus -6? What's -2 times -6? What's -2 plus 12? What's -2 times 10? What's 3 plus -20? -17. What's -2 times -17? It's not really that big. Good Lord, don't be dramatic. It's 34. What's 0 plus 34? 34. What's -2 times 34? It's -68. And what's -4 plus -68? -72. So we weren't even close. Suffice it to say, x plus 2, the guy's not even trying, right? Not even close to being a factor. So let's practice writing this out as a quotient plus remainder over divisor. This started as x to the 5. So what's my leading term going to be? X to the 4, because that's 1 less than 5. So here comes our answer. 3x to the 4th minus 6x to the 3rd plus 10x squared minus 17x plus 34 plus -72 over booyah. I feel like that covers it all, but I've been known to leave some things out, you know, in this line of work, it happens. So you have an assignment. It is on Delta Math, and I would be happy to do a question or 2 or 3 with you. You do not need to get it done today. I would, however, think it's reasonable to say that you should probably get a couple done before you leave, and then we'll pick it up tomorrow. So I'm going to pause this recording, but if anyone has any questions, then I'll bring it back up.